Okay, so good morning, everyone. It is Thursday, July 13th. And so it's nice that I get to teach you in one of these videos. I am teaching 3 math courses, so it's been nice that there are videos elsewhere. But there wasn't one for today's lesson and for one of tomorrow's lessons. So it's nice to kind of touch base. It is 7 a.m. and obviously I want to get this done and get my day started. So my hair is a little wacky. So this little avatar looks a little bit better than I do at 7 a.m. And so we're going to get started. I hope that everything is going really well with the course. If you have any issues, you can always email me or message me on the Microsoft Teams. So far, everyone is doing really well. I don't have any concerns. So keep up the great work, and we're almost halfway done. So it's going great. I'm proud of you guys. So hopefully my tablet here is going to work. For some reason, it's hit and miss. So when I write stuff down, I do need to clear it before I go to the next page. So you might want to pause here and there just to write things down if you're not going at the speed that I'm going, which is totally fine. So you do have quiz number 4 that's due today on logs. And so you've also got the lesson that has a really large gap here. And for some reason, it's not going to work. That doesn't matter. And so we're looking at applications of log today. I need my marker here. Technology is so fantastic. There we go. Okay. And so it says to solve for x in the following equation. This is supposed to be a 2. I'm going to change that before I post the work package for you guys. And this is also supposed to be a 2. Okay. And so this should be review for you. So log 2 of x minus 6 is equal to 4 minus. I'm going to put this a little straight so I'm not writing sideways. Log 2 of x. Okay, so what we're going to do is we're going to add log 2x on both sides. Log 2 of x. That cancels this guy out. So we have log 2 x minus 6 plus log 2 x is equal to 4. And so this can be simplified to x minus 6 times x because they have the same base here. Oh, that was my bad. Okay. And so that can be simplified to 2 to the exponent 4 is equal to, so this should be review for you. It's the word problems that we're looking for today. This is 16x squared minus 6x. So you're gonna distribute these guys. 0 is equal to, so we're bringing our 16 onto that side. Okay, you're going to factor that and it gives you x minus 8, x plus 2. And so x minus 8 equals 0 gives you x is equal to 8, which is a positive. So our x is equal to 8. And then just to show you there. So this is a negative, and so we reject that one. Okay, so this is our answer. Okay, so like I said, take a second there to write that down if you need to. And I'm going to clear it to move forward. So the pH scale is used to measure the acidity or the alkalinity of a chemical solution. So for example, if you have a pool or a hot tub, you might have heard of this before. And so we use the equation negative log H plus, where H plus is the concentration of hydronium ions, measured in moles per liter. So this is an example of when we would use log in like real life. Okay. So when our pH is 0, it's an example of like battery acid. pH 1 would be like your stomach lining. pH 2 is lemon juice and like gastric acid and vinegar. 3 is grapefruit, orange juice, soda. 4 would be like tomato juice or acid rain. 5 is soft drinking water or black coffee. 6 is like your urine and your saliva. 7 is pure water. 8 would be seawater. Baking soda is 9. Great Salt Lake and milk of magnesium is 10. Ammonium solution is 11. 12 would be soapy water. 13 would be bleaches and oven cleaners. And then 14 is liquid drain cleaner. Okay. So at 7, so where it stops at urine and saliva, it goes a little bit neutral. And so at the very top is very acidic. And then at 7 is neutral. And then at 14 is a lot of alkaline. Okay, so answer the following pH scale questions. So we're going to take a look at those right now. So tomato juice has a hydronium ion concentrate of approximately 0.0001 moles per liter. What is the pH? Okay, so we're going to use our equation where pH is equal to 0, or my goodness. This is what happens when I do this at 7 a.m. Okay, so log of 0.001. Okay, if you throw that into your calculator, it's -4, and you keep your negative, that's 0. Okay, and so your pH would be 4. Okay, so blood has a hydronium ion concentrate of approximately 4 times 10 to the exponent 45 moles per liter. Is blood acidic or alkaline? Okay, so we do our pH is equal to negative. That's supposed to be capital H. Excuse me. Log of our H ion, which is, oh, this is supposed to be -7. That makes no sense. There we go. That'll be fixed for you. So 4 times 10 -7. Okay, so if you throw that into the calculator, it's about 6.4. So since this is, and I'm going to type this part out. So since this is below the neutral value of 7, blood is acidic. Okay. So again, write that down, and I'm going to clear it. And so orange juice has a pH of approximately 3. What is the concentrate of hydronium ions in orange juice? Okay, so our pH is equal to 3. And we don't know what our hydronium ions is, so that stays into our equation like this. Okay. This becomes -3 is equal to log times our H plus, which can then be 10 -3 H plus. Okay, so our hydronium ions is 0.001 moles per liter. Hopefully that makes sense. So our equation here is what is most important to remember. And then we're going to look at the decibel scale. So I'm going to clear this. So some common sound levels are indicated on the decibel scale shown. The difference in sound levels in decibels can be found using this equation. Okay, so B2 minus B1 is the difference in sound levels. So in decibels, and your I2 over I1 is the ratio of their sound intensities, where I is measured in watts per square meter. Okay, so we're looking at how loud things are. So rockets are 200, so it's potentially fatal. A jet engine or rock concert speaker is between 160 and 150, which is a pain threshold. A symphony is 120, maximum stereo output is 100. Niagara Falls is 90. Normal city traffic is 85. A shout is 80, so protective hearing equipment recommended. A normal conversation would be at 60, a whisper at 30, and a rustle of leaves at 10, which is barely audible. Okay. I like that it's on a scale and it kind of shows you what to expect in terms of numbers. You know, if the question has something to do with whispers, obviously something's wrong and you're getting a big number. So our equation is that B2, which is the difference in sound. So how many times as intense as a whisper is the sound of a normal conversation? So I can't go back up onto the scale, but if you look at the scale, a normal conversation was rated at a 60. And then your B1 would be your whisper, which was rated at a 30. Continue this equation, and we don't know what I2 and I1 is. So 30 is equal to 10 log I2 over I1. We're going to divide both of those by 10. That cancels that out. This is equal to 3 is equal to log. So this is, okay. And so your I2, I'm going to actually write this as an I here, will be equal to 1,000. So a conversation sounds 1,000 times as intense as a whisper. Okay. So just as a recap real quick, you can use log for pH levels. You can look at logs for decibel scale, so sounds. And then we're going to keep going with the other ones. So I'm clearing this. So the sound level in a normal city traffic is approximately 85. The sound level while riding a snowmobile is about 32 times as intense. What is the sound level while riding a snowmobile in decibels? Okay, so we don't know what the sound level for the snowmobile is, so we're going to keep that B2. We're comparing it to normal city traffic, which is 85. 10 log, and we said that it's 32 times louder. Okay, so B2 is equal to, we're going to do plus 85 on both sides here. So the sound of our snowmobile is our B2. So 10 log of 32 plus 85. If you throw that into the calculator, it gives you about 100 decibels. Okay. I'm gonna take a sip of my coffee here. Okay, so I'm gonna clear this and we're gonna look at the Richter scale, which is used to measure earthquakes. And so we use the equation M is equal to log I over I0, where I is the intensity of the earthquake being measured. And then your I0 is the intensity of a standard low level earthquake. So fortunately, we don't really get earthquakes over here. I'm just really glad we don't get tsunamis. And so we're going to keep going. We've got an example for that guy. And then that's it for today's lesson, which is pretty easy peasy. So how many times as intense as a standard earthquake is an earthquake measuring 2.4 on the Richter scale? So I need my pen. Okay, so our M is 2.4 is equal to log of I over 2 or 0. My goodness. Okay, let's throw that into our 10 powered. Okay, and so our I over I0 is equal to 251.19. So it is about 251 times as intense as a standard earthquake. Okay, so I'm going to clear this, and we've got a B part, which is super short, and you're good to go. So what is the magnitude of an earthquake 1,000 times as intense as a standard earthquake? Okay, so your M is going to equal log of 1,000. You throw that into your calculator and it is 3. So I did throw 3 new formulas at you today to make your life easier for both the exam and your assignment. I suggest that you either create yourself a formula sheet or you highlight those formulas. It'll really help you out instead of like trying to go through your pages all the time looking for it. Okay, so just look for those keywords. You're looking for your pH levels, your Richter scale, and then your sound on your decibel scale. Okay, so good luck today. You do have independent questions that go with that. You do have a quiz that's due to me. It's a pretty short day, so if you have any missing assignments that are due to me, please focus on those. Otherwise, enjoy the nice weather. Hopefully it doesn't actually rain.